So today we discuss chapter 7, alternating current. So discuss alternating current, mean AC current. Okay. So there are the two types of source, AC source and another is a DC source. AC and DC. DC stands for direct current and AC source means alternating current. Okay, that's the name suggests, alternating current. Alternating means after some time interval the direction should be changed. That means alternate. Okay, with respect to time, current actually there's a direction will be changed. Also the value also be the change. Okay. So current and voltage, the only voltage are varying with respect to time, and the main difference of AC and DC, that a constant. DC is a constant and AC is a varying. The main difference is here. Okay. So DC is look like a flat line and AC look like a sinusoidal curve. Because that certain time there is a +1, suppose there is a -1, after some time their direction should be minus direction. That's a varying. That's a AC source. In this chapter we study, actually our class 12 board exam syllabus is AC source. Okay, apply AC to the passive device. Applied AC to passive device. Passive device means those devices who obey the Ohm's law. Obey Ohm's law. And there is a resistor, inductor, and third device is capacitor. We know these three devices, and here in syllabus AC, okay, alternating current and AC source is applied. Okay, the potential, obviously the potential applied to this passive device. Okay, so whole world main supply is AC supply. Okay, main supply is AC. Why AC not DC? Because in our home, office or university, any office or okay, that some device need very high voltage or some device need a very small amount of voltage. Suppose in India there is a 220 volt supply, 220 volt AC source, and some device in our home need a 10 kilovolt and some device need only 5 volt. And when you use the step up transformer, they step the voltage up to 10 kilovolt and then step down the voltage up to 5 volt. So we use transformer, okay, and this is a step up transformer, that is a step up because the output voltage is very high, that's the input as the output, and that is a step down. Okay, so because the voltages, output voltages, these are voltages very low. That's a AC source. If you use a 220 volt DC and the DCs look like a flat line, there's a DC curve, and it's very difficult to boost up to 300 volt or any other volt. It's very difficult, almost impossible. These are the possible to step up or step down because there's a constant possible. It's a constant, and here this AC is varying, and much more factor obviously there's a varying. That's why this AC supply we easily to step up or step down. That's the AC, and that's the main advantage of AC over DC. The main advantage is AC over DC. Okay. Okay. So So our syllabus only will focus the AC applied some ohmic device like resistor, inductor and capacitor. That's our class 12 syllabus. Okay, and we know the what is the AC and DC. This is a flat line, AC is a variable. Okay. Now the current. Another important is what is the AC voltage and what is the AC current. So now then AC supply or AC voltage, okay, in our home, current driven by the circuit is called AC current. When some device in source is AC voltage and the current that circuit is a AC current. Current driven by the circuit okay, is AC current. Actually AC current is C stands for current, okay, alternating current. So those devices are supplies the AC voltage source and the circuit of that current is AC current. Now focus on main syllabus. The AC voltage apply on a resistor. First device, a resistor. So AC source is applied on a resistor R. Circuits look like this. There's an AC source, the sinusoidal, the AC source, and there is a resistor R. Okay, and there is a series connection between source and resistance R, resistor R, that is EMF, that is equal to V equal to maximum voltage sine omega t. We know that. Okay, as a AC voltage source. This voltage source is AC source. Now apply KVL here. Okay, so current direction, one direction suppose there is a direction current or opposite direction of current because there is a switchable. Okay, after some time, after some we get a current direction is reversed. That's why they are AC. Okay, so the at I, so from KVL, so that is equal to EMF of function time t, that is equal to I times R. That's EMF is function time t, that is equal to, that's Vm maximum of that AC voltage, Vm sine omega t, that is equal to IR. So here I equal to Vm by R sine omega t, and that's Vm by R. Okay, here we discuss the current driven in the circuit is a AC current. Okay, so that current is AC current. So these are the AC current, and the Vm by R, that is that if we compare these two, that is we know the I equal to Im sine omega t. So maximum current Im, that is equal to Vm by R. And why these values maximum, from previous class we study. Okay, see that in previous class we discuss. Okay, you see that that's the that is epsilon naught. That's the maximum value. Okay, that's the max value of the EMF. Okay, that's the epsilon naught we discussed in previous class. Now that's why the maximum current. Okay, that's the max current. Okay, that is Vm by R. Now look at a diagram. Okay, suppose diagram very carefully. A diagram. Okay, and these these are the voltage source, and that's the Vm. That value is Vm, and this represents a voltage. Now here is the current. and that's represent I, and that maximum value is called Im. So here these are the Vm, and from here to there that is a Im, maximum current. Okay, and see the diagram very carefully. These this is called 0 degree. Suppose these are called maximum value from a pi by 2. Here is a pi, that is, that point is 3 pi by 2, and that is a 2 pi. Okay, and you see that Vm and Im at maximum value shows at pi by 2, and minimum value shows 3 pi by 2. There's a maximum and here is a minimum because that is a minus. Okay, max and minimum, and shows 0 at 0 degree, at pi, 2 pi. So current and voltage are in same phase. Okay, here you see that current and voltage are in phase. So here the circuit, the current and voltage are in phase. Same phase, not out of phase, because the same value, maximum value, show at same time or same angle. Okay, that's why these are in phase or same phase, current and voltage. So when a AC voltage source apply on a resistor in series, so you get a no phase difference here. The phase will be the same. Okay, current voltage are in same phase. Now calculate power. Actually, there is a mathematically. Okay, now calculate power. Okay, so power equal to, we know that is I square R, and here is I square. Keep in mind that I square, that is equal to Im square, maximum current, sine omega t times R. Okay, that's the power, and here is the average power average, that is equal to, or called mean power, that is equal to this bracket represent the mean, Im square sine omega t, if I, sorry, obviously there is a square, so sine square omega t times R. So Im square times R out of that bracket, because there is a constant, so variable is sine square omega t, that's the variable. Okay, how to calculate the average power? So very important. Now calculate these terms. Suppose you consider that a function of t, say that is a function of t. How to calculate that average of sine square omega t? So function of t, that is equal to total from 0 to t. Why 0 to t? Because t's value is time 0, and that is a t time. Okay, here we discussed in previous class, that is 0 to t. Okay, 0 to t. Okay, a full cycle from 0 to t, 0 to t, sine square omega t dt by total, that's the average. So that is 1 by t, suppose multiply 2, 0 to t, that's the integration, 2 sine square omega t dt. So 1 by 2t, 2 sine square omega t, that is equal to 1 minus cos twice omega t dt, integration 0 to t limit. Now you see that 1 by 2t, so the integration 0 to t dt minus 0 to t cos twice omega t dt. So 1 by 2t, integration 0 to t, we get only t, and that cos integration is sine 2 2 omega t by 2 omega, that is value 0 to t. So 1 by 2 t full cycle time period t. So 1 by twice omega sine 2 omega capital T minus sine 0 will be 0. So 1 by 2 t minus, so that is 1 by 2 omega sine, okay, omega equal to 2 pi by t, 2 pi by t times t minus 0. That is 1 by 2 t minus sine 4 pi, 0, the whole term with a 0 here. So get 1 by 2. So we get sine square omega t, that function of t, we get the power average, that is equal to Im square r by 2. Okay, that's the average power. Now here the special value of current. Now introduce the special value of current. Special value of current is called RMS current. It's called RMS current. Means root mean, that's called square. Root mean square current, that's called RMS current. Okay. So IRMS we get actually. So IRMS, that is equal to get Im by root 2. Okay. So how to calculate and suppose derive that expression. Okay. Derivation of this expression. Okay. So how to get prove that? So root mean square calculation, that is equal to I RMS, that is equal to, first the right side, from right side to left side, square, mean and root. So current square, mean, bar represent mean or average, and finally is root. So square, mean and root. Now here I square means Im square sine square omega t, and that's the mean. Okay, so sine square omega t mean. Okay, now calculate Im square sine square omega t. Now calculate the mean of that value. Okay, so mean represent the similar condition here. If that is a function ft, how to calculate that ft? The mean means the mean that is equal to the function of mean ft, that is equal to total time 1 by t, that is 0 to t Im square sine square omega t dt. Now these are the similar integration. Okay, these are the similar integration like this. Okay, and we get final value, that is equal to the Im square outside the integration by t, that is 0 to t sine square omega t dt, that is equal to Im square by t, that is equal to this value we get, suppose 2 here multiplied by 2, and it is 2, get only t here. Okay, and the final result, these t cancel, so Im square by 2, and this integration, okay, solve here. That's why we repeat that step. Okay, we can calculate here. Okay, now that's the mean here. So finally get mean is Im square by 2. So after remove the root, Im by root 2. Okay, that's the RMS proved. Im by root 2. Maximum current by root 2. Okay. Now if you calculate that the RMS, these are the called RMS. So I RMS here, I RMS root mean square, that is equal to maximum current, max current times 0.707. Okay, so root 2 equal to 1.414 and 1 by root 2, that is 8 by this, we get this one. So that is a 70% of maximum current, that is IRMS. Okay, keep in mind 70% of max value of current. So the average power, that is equal to P average or mean, we know that is equal to Im square R by 2. Okay, and we get from here average power Im square R by 2. Okay, and this Im square by R, so Im square by, so here Im square by 2, so that means I RMS square, because I RMS equal to root mean square current equal to Im by root 2. If I square both sides, we get I RMS square times R, that's the P mean. Okay, now RMS voltage, how to calculate the RMS voltage? So RMS voltage, okay. So RMS voltage, that is equal to V RMS, similar like current, so that is maximum voltage by root 2, max voltage by root 2. Suppose the 70% of Vm, peak voltage, maximum voltage. So here from Ohm's law, that is Vm equal to Im times R, and this expression we get from here, from starting, is Im, that is equal to Vm by R, max current, and we put here that Vm equal to Im times R. So if I multiply root 2 both sides times R, we get V RMS, that is equal to I RMS times R. Okay, easy. Now here we solve some example. Take an example. Suppose some example. Okay, suppose in our supply 220 volt AC. Okay, and keep in mind one thing, we forget discussion here. The AC is another advantage over DC. It's called long distance advantage. It's called AC is long distance advantage. What is long distance advantage? If R equal to rho L by A, see that is L, R is directly proportional to L, length of the conductor. If length is very high, so R also high. So I live in Kolkata and our power supply in Kolaghat power station. Kolaghat to my house almost 80 kilometers. In 80 kilometers, the resistance is very high, because length this length L is 80 kilometer, the resistance also very high. If resistance is very high, that is drop of current. Okay, so now, and that is also equal to V equal to IR. Okay, if R also very high, okay, V high, and but current is drop here. If current is drop, that's very tough. Okay, if current is dropped, obviously the potential also drop. Now we change the help of transformer. We change the concept with help of transformer. We boosting that potential, boosting that potential from desired output. Okay, after 2 to 5 kilometer, we put a transformer and transformer boost that loss potential. Okay, and loss and maintain the same value of 220 volt power supply. Okay, that's the advantage of AC over DC. But here DC, there is no use of transformer in DC because DC is a flat line, a constant line. That's why very tough. So DC is disadvantage. Okay, DC. Another disadvantage is DC. DC to convert AC. DC to AC is impossible. But AC to DC is a possible. Some circuit we convert AC to DC. AC to DC is very easily possible. In our some home appliance, we needed some DC voltage source. So AC to DC convert is very easy, and some device or some circuit make AC to DC voltage. So that is very easy. If I get a DC voltage and convert DC to AC, that's difficult, impossible. DC to AC because DC is a flat line. Okay, now jump to that question here. In Kolaghat power station, release a 220 volt AC supply. Okay, so calculate what is the maximum value of this potential Vm. Okay, so the Vm, that is by root 2, that is equal to Vrms. Okay, so Kolaghat supply Vrms, that's the Vrms. Root means square supply. Okay, so the Vm we get, that is equal to root 2 means 1.414 into 220 volt, and we get approx 311 voltage. That's the peak to peak or maximum peak voltage. Okay, the peak to peak voltage. And now I have taken another example. For better understanding. Suppose we given 100 watt. Okay, 100 watt power and a 220 volt AC supply. 100 watt and 220 volt AC supply. Power is given, voltage also given. Here power is watt and voltage is a 220 volt AC source. Okay, calculate the resistance first. So power equal to V times I, and I equal to V by R, that is equal to V square by R. So R equal to V square by P. So here V square means 220 whole square by P is 100 watt. So 220 square means 484 20. So 0 cancel, 484 ohm. Next question, question number 2, given what is the maximum voltage Vm. Okay, we calculate here maximum peak voltage, if that is equal to root 2 times Vrms. So in Kolaghat supply, the AC means RMS supply, that's a root 2 some RMS. RMS, that is 1.414 times 220, we get approx 311 voltage, like that. And the third question is question number 3. We will discuss. So what is the current? Okay, if voltage and power, so current equal to P by V. Power is 100 watt and V is 220 volt. Okay, watt by volt. So finally solve this, we get a approx 0.45 ampere. So these are the approx value. Okay, now we took some better understanding, we draw a phasor diagram. Okay, representation of AC current and AC voltage by rotating vector is called phasor. So now for better understanding this voltage and current or RMS value, for representation of AC current, and voltage by rotating vector. Okay, is called, this rotating vector is called phasor. Phasor. Okay, and you know that there is a no phase difference here because voltage and current are in same phase. Okay, here I discuss is voltage and current are in same phase. So what is the phasor diagram? So now the phasor diagram is look like this. Suppose this line, okay, and suppose these are the current, and this line represent voltage. This black line represent current, okay. Now if there is a rotating vector, phasor rotate, and these are the rotate, and that is maximum Vm, and from here to there, that's the Im. This line is represent the Im, and here at that point here to there, that is a Vm, maximum voltage. Okay, the current and voltage are in same phase. Okay, but there is a difference. Okay, when you use a inductor and capacitor, so it changes that phasor, but here the resistor and okay, apply resistor, so that's why we get a in phase. Okay, so if rotating in that direction, that is called angle omega t1. Okay, and that, okay, v equal to vm sin omega t, that is I equal to Im sin omega t. Now I draw a phasor here. There is a maximum value of voltage here. This line, the maximum value of voltage is the maximum value of current. So the voltage diagram look like this. And the current is now look like this. Okay, now you see that these are the at that point there is a maximum value. Okay, and now at that point, okay, at that point, suppose the point is yeah, at that point is at that point, okay, here time is omega t1, angle is omega t1, that's the pi, okay, that's the 2 pi. Okay, that's the phasor diagram. This represent the voltage and this black represent the current I. Okay, that's the phasor diagram. Phasor is rotating vector, and this vector is rotating anti-clockwise. The phasor is rotating anti-clockwise. Okay, clear? That's almost a basic mathematics here. A little bit concept, but mainly there is an integration, difference, integration here, and some concept here. And the new concept here you discuss, the root means square. That's a very important concept here you discuss. Okay, so next class we discuss a AC voltage source apply on a inductor. Okay, so today in the class here, if you have any doubt, ask in comment section. I will try to give the answer. So thank you for your time.